Hello everyone. Today we're going to talk about Boolean Algebra for Target 3. First, there's rules 1 through 9. I'll identify them as they come up or point them out in the example shown. So first we have this example, a plus 1 plus a times a naught plus b. So first we start with the parentheses, but to point out, the pluses mean or and the times mean and, but I'm going to say pluses and times. So first we have a plus 1. A or 1 becomes 1, and that is the null law of one proposition. And then we have, in the parenthesis, we have a times a, which is just a, because anything times itself is just a. And then we have that knotted, so that becomes a naught. And then we have plus b at the end. And then we simplify that further. Anything plus 1 is just going to be 1. So 1 or b. And then again, anything plus 1 ends up being 1. Next, we have this example, c plus d naught knotted plus c times c naught plus d times 0. So to simplify this, our c just comes down, our d naught, the naught just cancels out each other, so it becomes d plus c times c naught becomes 0, and then d times 0, anything times 0 is just going to be 0. So it's like d and 0, it's just always 0. So then we have 0 plus 0, which is 0. Bring down our c and our d, and then our 0 kind of goes away because anything plus 0 is just itself, so we have c plus d. Next, we have our rules 10 through 12. These ones are a little more complicated, so I did more examples. So for 1, this is our distributive. I pulled out the DC because it's common in both. And remember, there's an and here. And then what's left over is our E prime, E naught, and F. And those just, when you multiply them together, you get E naught F. So our DC comes out front and E naught F. It's kind of like if you pulled the DC out of both of these up front, and then you were left with E naught and F. And that's kind of what happened here. Our second example is a little more. So we have A naught, B naught, C naught, plus A naught, B naught, C, plus A, B naught, C. So I kind of pulled out the A naught, B naught because it's common in both of these. And then you're left with C naught plus C, and C naught, anything not plus itself is a 1. And then I just pulled that down. So we have A naught, B naught times 1 plus A, B naught, C. Next we pulled out the B naught down here, and then we have A naught plus AC. And because we have an A naught as our leading term, this A right here kind of just goes away. So we have B naught times A naught plus C, and then I distributed in the B and the B naught, and it becomes to this. Next we have this problem, x naught y z plus x. And then I just kind of rearranged it so I could see it better. I'd like to have the single terms out front. So we have x plus x naught y z. So right here, because there's an x and an x naught, they just become x because that is the leading term. And then yz is just kind of added on after. Next we have 4. So a plus axy. So we have a plus a here. And then we have this xy naught. So I kind of separated it so I could see it a little bit better. And then because it's a plus a, anything plus itself is just a, and the x and y naught kind of just go away. It doesn't really matter at that point because it's like a or a with stuff, it just becomes a. Next, we have our De Morgan's theorem. This one does get pretty complicated, but we're going to run through it kind of quickly. So here we go. So we have x, y, z knotted and y, z knotted plus x, y, a knot to the knot. So I separate everything. I get rid of these groupings so the knot is distributed throughout all. And when we distribute them, then we have to change an and to an or. So that's where we get these plus signs at. So we have x naught plus y naught plus z naught, and because it wasn't together, it's still separated there. We have y naught plus z naught plus x naught plus y naught, and because a was already knotted, it just becomes a. Now, I distributed this long thing, and that's what we get here. I'm not going to say all of this, but you can see for yourself. So it all gets distributed, and then I just pulled this term down. Now, when I simplified this, I went ahead and canceled out these double terms here that you see, the y naught and the z naughts, and that brings that down to simplify that. And then I liked to pull out the y naught, and then we have x naught plus 1, and anything plus 1 is just going to be 1. And then same with here. So that becomes y naught 1, and then we have our z here. And because there's two z naughts here, I left it up here and combined it, all of these terms here. So the 1 came down here, and the x naught and the y naught came here. Now, because of this term, this gets a little more tricky, but we'll see. What it comes out to be is y naught plus z naught plus x naught plus y naught plus a. So we have all these terms right here, but what happened to all these terms? But because there's this 1 in here, these all became 1, and then z naught times 1 becomes z naught. So then you have y naught plus z naught plus x naught plus y naught plus a, but we have two y naughts. So we're going to simplify that. We only need one of those. So y naught plus z naught plus x naught plus a, and that's the solution. Thanks for joining me in my demo. Have a good day.